Okay, this is the online learning lesson for Monday, January 9th. This will be our introduction to verifying trig identities. You'll find that these are very similar to what we worked on Thursday and Friday in simplifying trig identities. The difference being, instead of just trying to make the expression as simple as possible, we'll have to manipulate an expression to make it look exactly like some other expression. In this case, we want to manipulate secant of theta times cotangent of theta to make it look like cosecant of theta. These ones are very simple. They will get a little bit more interesting as we go along, but the basic strategy is you pick the side that's more complicated, and in these examples it will be obvious which side to choose. Sometimes it will be less obvious, and you just want to manipulate that side of the equation until it looks like the other side of the equation. So let's see what we can do here. Secant is the reciprocal of cosine, so let's try rewriting that as 1 over cosine of theta, and we'll rewrite cotangent as cosine of theta over sine of theta. Well, the cosines will cancel each other out, leaving us with 1 over sine of theta, which is in fact cosecant of theta, and it matches the other side of the equation, and we're done. Example 2. Here again, it's very obvious which side is more complicated. This side is more complicated. So that's the side that we're going to work with. We're going to manipulate that expression until we get secant of theta. So let's try the things that look obvious. We will first, I'm going to leave sine alone here, sine of theta, but I'm going to change tangent to sine of theta over cosine of theta. And I'll go ahead and write this as a fraction as well. To that, we're going to add cosine of theta. Now, we'd kind of like to have a common denominator so that we can combine these fractions. So let's go ahead and multiply this term by, let's see, the denominator over here is cosine of theta. So let's multiply this term by cosine of theta over cosine of theta. That should do it. So multiplying the first term, we have sine squared of theta over cosine of theta. Multiplying the second term, we have cosine squared theta over cosine of theta. And we've seen very similar to this before, right? So adding the numerators together and combining them over the now common denominator, we have cosine squared theta plus sine squared theta, never mind that I reversed the order, doesn't matter, over cosine of theta. But we now recognize that cosine squared of theta plus sine squared of theta, that's our very first Pythagorean identity, right? So we're going to rewrite that as 1 over cosine of theta, which is, of course, secant of theta. And it matches the other side of the identity up top, so we're done. Okay, this is our last example. Again, our left-hand side of the equation is the more complicated side, so we're going to work with that side. And in this case, we again have a GCF. We've seen a GCF in our simplifying problems, so we're going to factor that out. Cosine of theta times 1 minus sine squared of theta. The first factor looks pretty good. We've got cosine cubed over here, and here we've got cosine, so if we can just manipulate this to make it look like cosine. Now remember, the first Pythagorean identity we had, sine squared of theta plus cosine squared theta equals 1. If we subtract sine squared theta from both sides, we end up with cosine squared of theta equals 1 minus sine squared of theta. And of course, this is what we have in our problem, so we'll just replace it with this. Cosine of theta times cosine squared of theta. Doing the multiplication, we have cosine cubed of theta, which of course matches what we had in our original identity. So we have been successful. Check It's Learning for your practice worksheet. Work through those problems, and I'll take questions on them online tomorrow morning and tomorrow afternoon. I will have virtual office hours tomorrow from 10 to 11 in the morning, and then again from 1 to 2 in the afternoon. You can email me or post questions on It's Learning. Email's probably the most reliable, and I will answer those questions during those 2 hours tomorrow. Have a great day, and hook 'em horns.